Thanks for tuning in today. If you're new to the channel, welcome. Hope you enjoy what you see here today. And if you're a subscriber or if you've been here before, welcome back. Thanks for your support, I appreciate it. Just wanted to show you what I'm looking at here today. The sun's shining, it's a beautiful spring day in North Wales. The buds are on the trees, the daffodils are out, and it's just a lovely day. So what we're looking at here is this is the tooling drawer in my lathe stand. So previous video I showed how I fabricated a set of drawers here, and so this is where I keep my turning tooling. So on the front here is my size A tooling, in the middle is size AA, and I'm just going to introduce how I utilize these, and which will lead on to how I set up tool libraries, or a tool library in the Newall NMS 300 DRO. You'll see on here that these tools are numbered, and it seems a bit backward because I've done them right to left instead of left to right, but the reason for it is that I'm right-handed and I reach for the tools with my right hand, and the most commonly used tools are here on the right, so I try to make it ergonomic for myself. So anyway, running right to left, this is my tool number 1, so I've labelled it up there so that I can see which tool it is, and then this is a CMMT insert, I think. I'll have to double check that. A couple of different DCMTs, right hand and the left hand, a chamfer tool, threading tool, passing off tool, and a boring bar. But the boring bar doesn't have a tool number at the moment, and that's because the position of the tool in the holder is not fixed. So I'll always use it as with the minimal overhang as possible, just to make it as rigid as I can make it. But for storage, that's how I keep it in the drawer. And if I had a deep hole to bore, then I'd have to move it anyway. So I don't have a tool number assigned to that one. And the size A tools don't have any tool numbers because I don't use them in the tool library in the DRO. And the reason for that is because the 2 degrees of freedom on the compound slide, which are not easily repeatable. So whilst the compound slide does have a dial on it with increments, I don't want to rely on that. And also the rotation of the compound slide can completely throw off all of my tooling offsets. Okay, so that's how they're arranged in the drawer, and I'll take you over to the bench now to give a quick example of how I use the tools for different features. Okay, so here's a little sketch that I did freehand earlier. It's not the best, but hopefully it will illustrate a typical kind of part that I'd be looking to machine on the lathe. And what I'm showing here is this is a piece of bar, so this would be held in the jaws of the chuck, and the dotted line here, or the dashed line here, is meant to show what the raw material looks like. So it's a length of bar that's held in the chuck of the machine. So if you can imagine that, and within that there's a component here. So it has a section here of thread, and it has a decent sized chamfer on the front. It has an undercut with a shoulder, and then a spigot here. And so along the bottom here I've got a selection of tools that I'd probably use to make this. So to begin with, I'd probably use tool number 1. And tool number 1 would be my roughing tool. It's a good tool. It's quite sturdy, and it's typically what I would use for roughing. I'd finish with it as well, but depending on the job really. And then I've got this tool here as well. So this is tool number 2, and this is a DCMT tool, and I generally use this for finishing, and mainly because the tip has a more acute angle on it, so it's probably less robust than the other tool number 1. And then I skip tool number 3 because tool number 3 is a left-hand DCMT, and then the next tool that I've got here is a chamfer tool. So this one I've numbered tool 4, and I'd use tool 4 for putting the chamfer on here and probably breaking the edges of everything else. And and then I have this parting tool. So this is tool number 6, and I'd use that for machining this undercut here to relieve the end of the thread. And then I skipped tool 5. So tool 5 is a threading tool. So that's an insert threading tool, and that's a 60-degree insert for metric threads. And that's the tool that I'd use to single point turn that screw thread on there. Okay, so they're the tools that I'd probably need to make this. I could make it in fewer tools. I could do without the parting tool probably. I could probably use this tool to machine a little undercut here, the DCMT tool I'm referring to machine that undercut. But it's a nicer job with a parting tool, and it's no real hardship because it's so easy to interchange these tools with the Multifix tool post. And the other thing that I should mention is that the solid tool post mounts, which I've spoken about on other videos. So if you're new to the channel, you haven't seen the other videos, then it's probably worth looking at the other videos to see how I made a solid tool post mount. And the good thing about that is that it's useful for orthogonal turning, and it adds a lot of rigidity to the machine. Small lathes, they suffer from deflection on the compound slide, but it really comes into its own when you set up tool libraries, because you've taken away the variable that is the compound slide. Anyway, I've mentioned that already. The other point to mention is about the rotational angle of the Multifix, and I'll just take you over to the lathe just to explain a bit more about what I mean. So what we have on the lathe here is the Multifix tool post mounted onto the solid mount, and what we have is the ability to index through a range of angles here, which means that if we needed to change the approach angle of the tool with respect to the workpiece, then we can do that. So my tool library is set with the tool post in the 9 o'clock position, if that makes sense. And what I could do if I wanted to is set another number of tools, or allocate a tool number to the same tools but in a different position, for example. So if I wanted to, I could do that. So let me just illustrate what I'm talking about. So that's how I would normally use this tool in that orientation there, and that's tool 1. What I could do if I wanted to is I could rotate that through a particular angle, and the indicator on the tool post tells me what angle I've indicated it to. And now if I wanted to, in the DRO, I could allocate a different tool number for that tool in that angular orientation. Anyway, back to the bench. So what I was just referring to at the machine there is up in the top right hand corner here, I've just sketched out kind of what a tool library would look like, you know, if you were to write it down and to put it on paper. But it's essentially a very simple database. Let me zoom in. So essentially it's a very simple database, and we only have 3 columns of data. So we have the tool number down here, and then we have X and Z offsets. So on the machine, let me get that in shot there now. So on the machine, if I draw in the coordinate system here, that's X and that's Z. So the X-axis is along the cross slide, that's orthogonal to the spindle axis, and then the Z-axis is the spindle axis itself. So what we want to establish with the tools is we want to define where X and Y0 is, and that's going to be different for every tool. That's why we have this tool library here. So if I compare these two tools here now, so we've got a chamfer tool and a normal right hand turning tool. You know, I could set X and Y0 for this tool at this point here. So after I've faced off, I could make this my datum there on the workpiece. So that would be my datum, and that's fine. So wherever I move the tool to, the DRO tells me where it is. So I could bring it into here, and that would be XZ0. So that's all okay, and I could machine all of these and all these features using the DRO. But if I bring in a different tool, it gets complicated, because all of a sudden this doesn't share the same geometry as that tool, so then I need to think about doing something different. So what I could do then is I could 0 DRO and say, okay, now I've taken a cut, I'll measure it, and these are the new coordinates for this tool. But then when I come back to this tool, when I come back to the first tool, which is this one, then I've got to change the coordinates back again. So it gets a real faff. Now, the beauty of the DRO is that you can just flip between tools on the readout and it compensates. And what happens is it takes this data into account, and it takes these offsets and adds or subtracts them to the absolute coordinate position on the machine. So it makes it a really handy thing, a really handy tool to have at your disposal. So hopefully I've explained that well enough, and I'll move on to give a demonstration on the machine now. Okay, so there's glare on the DRO, so I'm hoping that it's visible. I've tried to put like a little film on the screen of the DRO, because the reflection of the light just washes out the digits. I can see it by eye perfectly fine, but the camera, it's difficult to pick it up on the camera. So anyway, hopefully that's it's readable. Okay, so we're at the machine. I put tool number 1 in the tool post, and we've got some material in the chuck, and so what we'll need to do is pretend that you've just seen me chuck this up, and you know, I've been machining this beforehand, so I've been having a bit of a play around, and I'll just run through the procedure that I follow when I'm setting up my tool library in the DRO. Okay, so let's fire up the machine. So to begin with, let me just get the feed sorted out for the power cross feed. Okay, so I'm not going to be removing loads of material here. This is just to demonstrate how I do this. So what I'll do is, let me touch on, and we'll take just the facing cut here now. I'll lock the carriage lock with the new lever that I made recently. It's another video that you can check out if you like. There we go. Okay, so I'll stop the machine just to cut down on the noise, and now what I'll do is I'll set Z to 0. There we go. And what I'll also do now is there's a preset on these DROs. So if I press F1, so function 1, I have various options here now. So I can, and there's different ways of programming the DRO. So on the top right hand where my thumb is, which you can't see, but it's just out of shot, on the top right on the DRO, let me see if I can adjust this so that you can see it. So at the top right, I've got these arrow keys. So here where it says use, that's one option. I can teach it, I can program it, or I can delete it. But what I'm going to do is I'm going to select use, so I click enter. So at the moment here now I've got tool 1 highlighted. If I scroll across here, I've got various tools, and you can see that the X and Z coordinates change. And this tool now is offset by 0.2 of a millimeter. So what I'm going to do now is I'm going to set that to 0. So Z0 for tool 1 is in that position there. So I'll unclamp the saddle. And now what I'm going to do is I'm going to take a cut off here now, and then I'm going to measure the part. Okay, so I've got my caliper at the ready. If I wanted to be more accurate, I'd use my micrometer, but in the interest of time, I'm just going to use the digital caliper. So I'll start the machine up again. Change the direction of the feed. There we go. So let's take a touch on here. And now I'll engage the feed and take a cut. Okay, turn the machine off to quieten it down a bit. Oh, let's bring you there so that you can still see. Is it still in shot? Yeah, okay. So let's put a measure across here now. And that says 55.64, and the DRO is reading 65.62. So what I'm going to do now is I'll change that to 55.62, and that's tool 1 set. So if I was machining non-critical features now, I probably wouldn't need to measure the part again with this tool. I could rely on the DRO. But if I was machining any critical features, then I would obviously need to measure it and possibly make some fine adjustments to my tool calibration. Okay, now obviously depending on the depth of cut, the spindle speed, the material, and various other parameters, the accuracy of the part from here on in is really dependent on quite a few variables. So I've taken off here probably about a 0.1 cut, which would be typical of my finishing cut, depth of cut. So I calibrate all of my tools with generally the types of machining parameters that I would use for that material. Of course, this is aluminium, so if I put stainless steel in here, then the machining characteristics are going to be different. So that's why for finishing cuts and for accurate features, you're going to have to do a little bit more than just setting the tool library up. But for, to get somewhere near within probably 0.5, we're probably okay doing what we're doing. Okay, So let's take a chamfering tool now. So let's take tool 1 out and we'll put tool 4 in. Okay, so now on the DRO I'm going to go over to tool 4. The way I have this set, so I'm cheating a little bit because I've already preset most of these tools. What I tried to do is, rather than have the tip here in line with the corner of the workpiece, what I do is I aim to have it offset slightly, and I offset it by about 1.5 mm, I think it is. And generally I don't put chamfers bigger than 1.5 mm on anything. Normally it's about 0.5 mm, so I don't run out of land on the tool. So just to illustrate what I mean, so I've got tool 4 selected. So if I go to Z0 now, let's have a look. Okay, all right, we're 5 microns off. And if I do just a touch on there, so I just started to break that corner. That's at 56.32. So what I would do now is I change that dimension in X to be the exact number, and then I've got my chamfering tool calibrated, and then if I just show you the parting tool to show my approach for that one. So let's go over to tool 6. Right, so what I do with this one is I have this right hand edge as Z0, that's where that should be. So just by eye, I've lined that up with the end of the workpiece now. So what I have here is a gauge block. This is just an old gash gauge block. And what I do is I bring the parting tool up until it catches. So it's catching, you can hear it catching hopefully. So I just wind it back until it clears. Just go back and forth just to get it right. There we go. And what I do now is in Z, I'll set that to 0. And then I could do a touch on here now and calibrate the X axis as well. But it's there or thereabouts, so it's pretty good. Now then, it's a 2 mm wide tip. So let's say I wanted to put an undercut in there. Well, the way I would do that then, if I knew the dimension from the end face to that shoulder, then what I would do is move it over by the dimension less the width of the parting blade, which is 2 mm, and then I could come in there exactly in the right place, and then I could put an undercut. So I'll show you that. So this is just eyeballing it, but if I'd have done all the things that I just described to you now, then that's that done there. And then the threading tool is pretty much the same really, except what I do with the threading tool is I make the tip of the insert, here, can you see that? Hopefully you can. Then I set that to XZ0 right on the tip there, and that's how I do it. So I try to make sure that I leave an undercut wide enough for the width of the tool and enough space to run into, so that I've got enough reaction time, and that's how I set the tool library up on the Newall DRO, but it just makes life so easy. I don't have to mess around with dial gauges, and it helps me to machine parts more quickly and not lose track of where I am, and really add a bit of technology to the hobby, really. So there we go. That's what I've been up to with my DRO, and I hope that was of use for you guys. Your DROs, if you have them, are probably different to mine. The principles are all the same in terms of how they all work. But yeah, that was just a little explanation, or my little explanation and demonstration of how I set up the tool library in the DRO. Hope you found it useful. Thanks for watching, and I'll see you again soon. Bye for now.